So, in order to create a new project, first of all, we need to select a new project and give the name to the drawing that we will have. For example, let's select presentation and the date. And select save. So now automatically a new DWG file will open, and on that WG file we can see that the path is inside a BLD. In that folder, all the necessary files will be saved on that path. Now, in order to start creating, we can start drawing from scratch. For example, we can start drawing walls from scratch, or we can insert a different DWG file, a PDF, an image, in order to start drawing above that file. For example, on that drawing, let's say that we have the DWG files, and I'm going to insert those files in order to have something as an external reference and start drawing above that. So I will go to definition, building definition, and I can select the name, for example, of my floor, the elevation, the height, and the DWG file that I want to attach as an external reference. So I'm going to select here, for example, an DWG file. I will go to desktop and I will see some of my XREFs. Let's select, for example, the level 1 file and select open. Now I have selected that file, and that file will be placed on the first floor. For example, I can select to add and other levels with the adapt command, and I can see here the view of my building. Just for the example, I will select only one floor, and so I will select delete here, just to be faster. The procedure is the same floor. So, that's a very small external reference. We can select also a bigger one. For example, I can select on the second level and have, I can not see that because it was in Greek. So something like that, and I can start drawing, for example, that building, that space. First of all, in order to start creating all the building cell, I need to create the walls that we are going to use. For example, on the construction elements, openings, outer walls, and inner walls. For example, because I will have walls, and in one project I will use some specific elements about that project, I can define the elements that I want to use on that project. So I can select outer walls and select the elements that I'm going to use on that project. That means that I can select the outer wall, for example, number 1, and select library, and select the from that library the elements that I'm going to use on that project. So, for example, let's say that I want to select one that external wall which has a U factor of 0.5 and select accept. So now I can use that wall in order to create my building cell and select accept. The same procedure can be done also with the inner wall, the floors, the ceiling and the openings. I can select opening and select from the library some openings that I'm going to use on that project. And I can see the basic parameters about that. For example, I can see the U factor, the coefficients, and the frame. Let's select that I want to place that one and select accept. So now with that procedure I can define all the elements that are going to be used for the building cell. So on the definition menu, what more we can see? We can see the layer management. On the layer management we have the basic layers of the drawing that we can see, that we can select. For example, when I finish drawing the building cell, I can select not to see the columns or not to see the floors and the ceiling in order to be to select what I'm going to see on the drawing and what I'm not going to see. After that, we have the copy building floor. If we have typical floors, I can draw the building cell on one level, and after I can select copy building, select the floor that I want to copy to the second floor in order not to draw again the same building cell on a different level. We need to create the building browser, is that menu here where I can see the level that I'm currently drawing, the north direction that I'm going to place. I can change levels from here and some basic drawings that I can select. So now I'm going to building entities menu, where I'm going to start drawing my building cell. Here, let's say that we have only one space and one unheated space, for example, the stairs here. I can select all the commands one by one. First of all, the outer wall. On the outer wall, I can select the type. By selecting type, I can see the previous window on which I can see the elements that I'm going to use. For example, I'm going to select now the external wall and select accept, and I can select the elevation, the height and the thickness of the external wall. Also, I can select the beam that the wall will have, accept, and also if I want to place thermal bridges on that wall. If I select thermal bridges, I can select, for example, if the thermal bridge exists, the type of the second surface. For example, if I have a thermal bridge between the wall and the roof. I will select here the roof that I have the thermal bridge, and I can select the drawing that I have and fits more with the insulation and the building cell. For example, if I have select here the thermal bridge up with the ceiling, so I can go to the roof thermal bridges and select the best drawing from what I have. For example, if I will have the insulation outside of the building's cell, I will go here and I can see the insulation, the bricks and the beam and the floor here. So maybe I will have something like that one here. So I will be to 22. With the same procedure, I can select if I have a thermal bridge with the floor down, or maybe with the different element. So I can select here the thermal bridges and select OK, and after that accept. So now I can give point by point all the first point of the wall, the second point of the wall, and the side from where the wall will take the width. And after that, second point width, second point width, and like that I can create my building cell. I have placed all the external walls now. Now I need to place the inner wall that separates my thermal zone with the non-heated space. Also, if you can see here, I have selected the width to be 20 centimeter, but it was 25 in the drawing. I haven't checked it, so I can very easily select all the walls, go to the width, select 25, and the wall will be modified. Now, about the inner wall, I can select inner wall, select inner wall to unconditioned space, and select again all those parameters that we had to select previously. Elevation, height, thickness, the beam, and the thermal bridges if we have. So I will select again 25 the thickness, select accept, and I will give point width, and I have my building cell. After that, I need to select windows. I will go to the window command, and I can see the type again that we have, the height, the rise of the window, and the length that we are going to see. Also, I can select the type that we have on the drawing. For example, here from the select, I can see the type on the 3D, and I can choose between different types. I can see it as a slide or on the 2D here. So I'm going to select that drawing, select OK, and after that I'm going to select the height For example, 1 point to the rise 0.9, 1 point to the length and height, and I will need to select first of all the wall on which I'm going to place the opening, the first point and the second point. So now I can place the opening. Again, the same procedure, select accept. First I will select the wall, first point, second point, and I can select the label, or by clicking escape I just cannot place the label. After that I can place the doors. Again, the same procedure. I will do it a little bit faster. It's the same procedure. I can select a different type. I can select the high rise length and the thermal bridges. Accept. First point, the wall. First point, second point, and where the wall is going where the door is going to open. So very fast, and on the other door. The door has been placed. So I have placed walls, inner walls, openings and doors. Now I need to place the columns, if I have columns. The columns can be placed with the placement command. So I will select placement, and with the same procedure I can select the thermal bridges here if I have, and I can select the width and the thickness of the column, or if I do not check the that command, I can give one point by point the column. So first way is to select the width, the thickness and the angle of the column and select accept. So the column will be on the cross and I can select where to place it. That is the first way. The second way to place a column is select again placement. I will not select that command and I will give points. On every point I will check one by one all the points where the column will be placed. Right click and accept. So the column can be placed like that. Also, just to see, I will make that one. I will select again placement, points, all the points on one. Accept and place the column. So, and the columns have been placed now, and we need to place the floor and the ceiling. Let's place first of all the floor. Very easily. I can select the type of the floor from the typical elements that we have placed on the beginning. The adjacent space, for example, if it is neighbor to the ground, let's select and select accept. Now I will need to give one by one again all the points of the floor. So I will select one by one the floor, and I can see here that it has been recognized. With the same procedure, I can place the ceiling. If I have a roof, I need to place first of all the roof, and after define that roof as a ceiling. What I mean, let's say that we didn't have a ceiling, let's say that we have a roof, a four-sided or an anisoclinal roof. Select accept. Just for the example, I will make it a little bit faster in order to see how we are going to place it. Again, I place one by one all the points of the roof, and we can see that the roof has been recognized here. It has been in the drawing, but that roof is not recognized for the calculation. In order to recognize that roof for the calculation, I need to select ceiling and say select roof here and the type of the roof. So I'm going to select roof, I'm going to select the roof and accept. And now I can see the floor one and the ceiling one. And if I select it, I can see that it is recognized. So I have selected everything about the building cell. I have drawn everything about the building cell on that point. Now I can go to drawing calculations and I can see some basic, some more commands. First of all, plan view, 3D view. 3D view is the 3D of that level, and axonometric view is the 3D of the whole building. So let's select 3D view. We can select here the realistic command in order to see the view of the building. Note that the floor is not drawn as a building element. It is just like that. And again, let's go to plan view. Now I will go to definitions again and select layer management, because I have placed the roof, floors and columns, but I don't want to see them on the drawing from that point. And I will close that layers in order to see the drawing a little bit clearer. So now I need to select the space definition in order to define the space that we have, space definition, and click one point inside the space and one point outside. And as you can see, the walls have been selected now. So I'm going to give a name on that drawing, on that space. Now, maybe I will not need to calculate the thermal loss or cooling loads to the unheated space, so I'm not going to place it. I could select space definition by point again and select that space here, but it is not conditioned, so I will not place it here. Again, I can select now the shades due to vertical cantilevers and horizontal cantilever slab. For example, horizontal cantilever slab means, let's say vertical cantilevers first, select accept, and we know that wall is going to shade that wall. So I will select the point here and the wall that it shades and select accept. And now I can see that that wall is shading that wall here. Also on the horizontal cantilever, I can select the cantilever that I have, the one by one the points. On that XREF I cannot see a cantilever, but let's place it just for the example, 1 point. On the 3D is going to be something like that. And that cantilever is going to shade the wall and the window. So now I need to double click the cantilever, select attach and select the wall that is going to shade. And after that, 1 point on the cantilever. So now everything that is going where we need to draw about the building shell is finished, and I can proceed with the thermal losses and the cooling load calculations. So I can select thermal losses, update from drawing, yes. And the calculation software will open. So here I can go first of all to Files, Update from Drawing, select yes, Calculate yes. So everything that I have drawn on the software previously is going to be recognized on that software. I can see some basic parameters. Let's take all the tabs one by one. Project data, project info is here we can find some basic parameters that are going to be printed. Project data, building parameters. We can select the city that the project will take place, and the external temperature, the indoor temperature, the mean temperature are going to be selected from the city. Automatically, if we change the city, those parameters will change. Also, we can select the different temperature between the heated spaces and the unheated spaces, the soil temperature, the calculation method that we have, the increment, and some basic parameters about the EN calculation method. We can select some calculation method, just like the DIN and the EN, and some ASTRA calculation methods. I think that at least in Greece, the most usable calculation method is the EN 12831, because it is also the latest calculation method. So I can select also some basic parameters about that calculation method. For example, if I want to calculate the correction about the heating. That means that on the night the heat network is not operating, so the building is going also to lose some temperature, and I can calculate that reheating by selecting calculation of reheating and the correction factor. That means how many kelvins I'm going to lose on that period of time. that is an assumption. We cannot find something that with a calculation. It's an assumption, and we can select it by the building mass, maybe of the building. Also, we can select if we have from the heated from the height of the heated space a correction factor, and select exit. So these are all the calculation parameters that I need to select. Also, I can see the structural elements. The structural elements are the element that I have selected on the drawing on the first point, the elements that I'm going to use on that project, and select OK. Also, I can select here window, and let's see all the windows that we have. All that windows can be also printed on RTF, PDF file format. So I will select cover page, and the cover page will be seen. Assumptions, thermal losses calculation sheet. This is the main sheet of the calculations. Here I can see all the levels and all the spaces that I have drawn previously, and I can see, for example, level 1, level 2, and the first space that I have defined previously. All the structural elements, the thermal loss of every element, and also here we can see the I1 and I7. This is the inner walls that are connected to the non-heated space. So on that space, on that elements, I can see the adjacent room temperature, which was defined here. The temperature with the non-heated space. Also, I can see all the wall, the orientation, adjacent room. Here all these are with the outsider environment. Ground, the floor one is with the ground. We can see if it is subtracted. Subtracted means that, for example, here we have the opening one. O is opening, W is wall, and I is inner wall. We can see that the opening is subtracted from the wall. That means that in the drawing we calculate, for example, here all the area of the wall, and we say that we have an opening on that wall, so we are going to subtract the area of that opening. And also we can see the parameters, length, height, surface, and the thermal losses. So here are all the calculations. We can see also all the data about the overall losses of the building, and some checks. So now all of those windows can be printed and linked to a Word software. and I can see all the printouts and all the calculations. Let's close and save. That is the thermal losses. We'll go again on the drawing, go to plan view, and we can select to update the space from the thermal losses and see the thermal losses on that space. With the same procedure, we can go to the cooling loads. Select update, select files, again update from drawing, yes, calculate, and we have the same menu. For example, we can go to project data and see some basic parameters, and again on the windows we have all the printouts and the main window, which is the calculation sheet, where we can see again all the structural elements of the building cell with the orientation, if they are subtracted, the U factor, length, height, and all the basic parameters about those elements. What we have more about on the cooling loads is the people load, the equipment load, as we can see here, people load, equipment load, heat gain from lights, and ventilation load. Those 4 parameters need to be calculated in order to see all the cooling loads. So there are 2 ways to place all of those parameters. If I select to place them from here, I can place the people only on that space, but also I can select to place them from project data, people, and if I select it from here, all the spaces that I will have defined previously on the drawing will have the same parameters. It's a little bit faster if I have typical spaces. So let's see here the project data that we have. Project info, again, is the main printouts from the headings. Indoor design condition, I can define the inner temperature that I want to have on my space. Building parameters, I can define the calculation method and also a safety factor for the load. Climatological data, I can select here the city that I want to make the calculations. Months, the months that I'm going to select for the calculations, and the reference month, which will be the most, let's say, heated month, and select OK. And after that, I can select the structural elements, which is the same as we selected from the structural buildings previously. Let's say here we can select people, as we told previously, and I can select the people that I will have on the space. For example, standing light work, and select selection. And after that, I can select the quantity of that the people. So I can select that we have 3 people. And after that, I can select also an operating schedule. For example, let's say apartment. So now if I select OK, we can see that that load from people is being calculated. With the same procedure, I can place the equipment. It's the same menu. I can select the equipment, I can select the quantity and the operating schedule. I can select the lighting load. Again, the same procedure. Select lighting. I will select the watts and the operating schedule. And last, I can select the ventilation. The ventilation will be calculated for every space separately. So I will select it from that menu here on the space. What I can do is the length and the height of the space is automatically recognized, and I can select the air changes per hour. So I will select that I'm on an apartment, and I will select 3 air changes per hour, OK, and also that load is calculated. So again, now everything is calculated and I can see the printouts that I have and the diagrams. So all those diagrams and calculations again can be linked to Word, and select Link to Word. With the same procedure. And I will close, I will save, and I will return on the drawing. Now, on the cooling load, I do not have an update so I can see the cooling load for that space, because maybe I want to place the cooling load with the air exchanges or the cooling load without the air exchanges. Every time is something different. And after that, let's sum up. We have created the building cell, and we have calculated the cooling load and thermal losses. And now I can go to the AutoNet menu. Here I can see all the networks that I can draw. For example, I can draw the single pipe system, dual pipe system, fan coils, air ducts, and in-floor heating system. If I select something here, the menu will change, and I can draw a different type. The drawing is, let's say, more or less the same for every network. The same will follow the same steps for every network. We have here a small building, so let's start drawing, for example, the two-pipe system. The procedure is the following. First of all, we first place where the radiators. I select the radiators. I can select the radiator that I want to place. Let's say that we have one radiator here and one radiator here on that space. After that, I'm going to select the collector. let's say that we have the collector here. So now what I need to do, I need to connect the radiators with the collector, and after that the collector with the supply point. The supply point can be a heat pump, can be a boiler, everything that I want. There is no limit. Let's select, we can select on that. So in order to connect the radiators with the collector, we can place the pipe just like we are drawing a line on every CAD software. I can select, for example, supply pipe, and I can select that I want to go from here. Let's select, I will give point by point, and here that I need to connect the collector. I will need to select the node snap. When I will select a star, always I'm going to use the node snap. And again, supply point, node snap. Let's go here. So I have drawn the main pipes, and now, for example, I can select the connect receptor to existing pipe. I will select that command. I will select the receptor, enter the pipe, and I can see that that segment is automatically drawn, and the remaining segment can be deleted. The same procedure can be made here. I will delete the remaining segment, and now I need to connect again the collector from the star here on the back to the supply points, heat pump, boiler, anything that we want. I will select supply start point and the endpoint snap. So a basic network is something like that. That is a basic network that I can draw. Let's save the project, and now what I can do, I can select the network recognition command. If I have made any errors on the drawing, that command will notify me. For example, if I haven't connected the radiator correctly, a message will appear that will inform me that I haven't connected the specific radiator connected. If I select the network recognition command and nothing appears, that means that my network is drawn, I have drawn my network correctly. So, after the network recognition, I can go again to the calculations. Again, it is the same menu. First of all, I need to select Files, Update from Drawing. Calculate yes. Again, I can see the basic project data and the windows that I can print. For example, I can see the calculation sheet again, which is the same, the main window, where I can see all the calculations and my network. I can see that I have a different, the network, the section, the pipe length, the radiator that I'm going to use, the temperature difference, the flow, the pipe size, the velocity of the water. all the fittings have been calculated and placed automatically. If I select the 3 dots here, I can see that, for example, on the segment 1.2, I need to have the collector and the bend. If I go to the drawing, I can see here that I have 1, the place 1, and 2 is the collector, and I have 1 bend and 1 collector. The software, because I have drawn only the supply network and I didn't draw the return network, automatically will duplicate everything about the length of the pipes and the fittings. So we can see here that I have 1 bend and 1 collector, but I can see 2 bends and 2 collectors because it's the supply and the return software and the return network. Also, the 7 meters is is approximately 3.5 and 3.5 supply and return, and they will add up on 7.397. So here I can see everything about my network. I want to note just to I can see that the call will automatically end in 3 minutes. It will end, it will close the call, but we can connect again with the same link. So in 3 minutes the call will close and we can connect again with the same link to continue to see the rest. So this is the main window. This is the main window. I can see I can see the network here. Again, on project data, I can select network, and on network, I can select the water temperature, the type of the pipes, the energy units, and the fuel type from oil, natural gas, boiler, heat pump. Let's say that we have natural gas. And I will select here OK. Again, on calculation sheet, window, I can see the basic printouts about cover page, assumption, network checking. That will notify me if I have a radiator with more than 20 degrees temperature drop, or if the speed is bigger than the velocity that I have placed here. I have the maximum velocity and the velocity on the network. So it will notify me if the water velocity on the network is bigger than the maximum velocity. Again, I can see the water storage tank calculations. I can select the number, for example, of the baths, number of apartments, and the water storage tank calculation will be made. And I will have here, for example, I need 6 kilowatts for the hot water. We can go to the boiler heat pump calculations, where we can see that we have 3 kilowatts for the network and 6 kilowatts for the hot water. So I need to select a boiler that can have 12 kilowatts. And from the 3 dots here, I can select So here we can select the boiler.
But share your screen.
Oh, yes, of course, I forgot. Yes, I have started it. So, here we can select from those boilers and I can select, for example, a supplier. Again, I can go to calculate a burner or a fuel tank with the efficiency, and I can see the hourly demand. I can calculate the circulation tank. Again, from the libraries, I can select a hydraulic calculation and select the circulator that I will have. I can go to select expansion tank and I can calculate also some basic parameters about the chimney, but there are basic parameters. After that, I can see the friction drop on the drawing and the bill of material, detailed bill of material, where I can see for every different diameter of the pipe how it's going to, for example, I have 7 meters for and 5 meters and again 7 meters for that diameter. And at least I can see the technical description for my network. I will close, and again I can select to print all those files on Word with the same procedure as previously. Again, I can see here all the printouts and the calculations. I will close and I will save. I will return the drawing, and now on the drawing I can make the following. First of all, I can select to update drawing. I will select update drawing, select all, auto placement, and I can see the labels where I can see the diameter of the pipe, the length of the pipe, and the velocity of the water. Also on the receptors I can see the watts and the type of the receptor that is calculated. Also I can select again update drawing, and I can select to update the receptor lengths. For example, as you can see here, the length of the receptor is that one. If I select update, user receptor's length, select OK, and close, I can see it was very similar, but the receptor length has changed. Also, I can select to convert single line to 3D, and if I see it on 3D, let's close the roof. I can see my pipes on the 3D. I can also select axonometric diagram. And a new axonometric, a new file, a new DWG file will open with that name, where I can see the axonometric. And last, I can create the vertical diagram for my network. So I can select vertical. Okay. And the vertical diagram will be created in a new DWG file. So this is the two-pipe system. The fan coil is the same. The drawing for the fan coil unit is exactly the same, and also for the single pipe system. So I prefer to see, for example, the air ducts now, and the in-floor heating system. The air ducts is the same procedure, but I can select to calculate some more things. On the air duct calculations, I calculate everything from the fan after the fan. That means that I calculate the fan, I can calculate the air ducts, I can calculate the grills, but I cannot calculate the heat pump, for example, that will give the that will cool the air. I can calculate everything from the fan and after. So I will use the same procedure. I will go to air ducts, and first of all I will place the fans. Let's say that the fans, I want to place the fans on a different elevation. I don't want to place the fans as previous on 0 elevation. So I will go to current elevation command and select 2.7. So everything that I will draw now will be placed on 2.7 high from the floor. So now I will select the grills. Let's select, for example, 2 grills. After that, I can select a different elevation for the air duct, for example 3.1, and select enter. And now I'm going to draw the supply air duct. Let's say that we go here and here. Now I can connect. We can see that the pipe is on different height from the receptors. I can select connect grills with existing duct, or connect grills with existing duct with a flexible one. So I can select the grills. I will enter. I will select the pipe, and after that I can select the type of the air duct that will connect the main air duct with the grills. So I will select, for example, that one, select accept, and automatically it will be drawn here. Again, I will delete the remaining segment I will select the supply point, and I will make also the same procedure for the return air duct. Now for the return network, I will select a different height, for example 0.8. I will select the grill, I will select again a different elevation, for example 2.8. The same procedure as we have seen on the previous network. I will place the supply point for the return, and I will connect the return grill with the air duct, and I will delete the remaining segment. So I have drawn now something like that. And now again with the same procedure, I can select network recognition. I haven't seen any message, so my drawing is correct, and calculations, and the calculations software will open. I will select Files, Update from Drawing, and again we have the same typical menu. So on the window calculation sheet, I can see the basic parameters about the I can see all the parameters about the network. I can see the network section, the condition space, the load that I want to calculate, that I want to have on the drawing, on the grill, on every grill. And I can see the airflow, the duct length, the speed, the air velocity, the fittings. Everything again can be seen on that menu. Now, on the network that starts with 1 dot and another number is the supply network, and the return network is that one. So the supply networks is with the dot. Again, project data, we can see the project info, where we can see the basic parameters for the printouts, and the network, where I can select the supply and the desirable space temperature. I can select the material of the air ducts, and also I can select the type, and if I have the energy units in megacal or kilowatt. So now the calculations have been made, and I can see here also the duct width and the height. So I know the size of my air ducts. I can go to Windows, Fan Calculations. I can see the airflow and the network friction. So I need to select a fan that can accommodate those needs about the friction drop and the airflow. So I will select the fan here with the 3 dots. That will have a flow rate bigger than 660, and the bigger than 3.1 and the pressure drop. So, for example, I can use something like that and select OK. I will select again section friction drop, where I can see the friction drop for every segment, bill of materials, detailed bill of materials, and the technical description. All of those parameters can again be exported to Word. That technical description should be on English. I don't know why it's on Turkish. Maybe I have made the Turkish installation previously. Let's change it again. Maybe I had a Turkish installation previously on my computer. So the technical description is that one. Again, I can place them all those printouts on Word. Let's save and close and return to the drawing. I can make again the same procedure. I can select update drawing, select all, auto placement, and all the labels will be placed. I can select convert single line to 3D. Where I can see the supply point and convert single line to 3D. Where I can see the network that I have. Here I think that I have placed something on the calculation wrong, that I didn't check it, because I can see a very big grill on the return pipe. Let's check it again. I haven't placed the airflow. On the return system, I need to place the airflow for the segment, so I didn't have any calculation. So here again, I need to place 600, the same airflow. Close, accept, and let's select again, convert to 3D, and see the network that we have. Something like that. And I can create also the vertical diagram. Again, the vertical diagram will be created on a different drawing, and it's a basic DWG file. So let's close it also that and select accept. Again, let's go to plan view. So now what we have is the in-floor heating system. This is the last network that we can draw. The in-floor heating system is not automatically connected with the drawing. That means that I can draw the network, but on the calculations I will need to place the network again. I will need to place the calculation sheet. Very easily, in order to place the drawing, I need to make a polyline first of all. I will select polyline, give the points of the polyline, and select close. So now I have a closed polyline, and I can select generate drawing. I will select the polyline, and after that I can select if I have a meandering or a bifillar drawing. Let's select bifillar. I will select the first point where it will enter, the pipe that will enter and the pipe that will go outside. The distance, between the sides, 0.10, and the distance between the pipes. So the network is being created. That network is just for the drawing, and in order to see that drawing, nothing will be placed on the calculations from that. So now I need to go to the calculations, and go to Windows, Calculation Sheet, Project Data, again, Network, and select the basic parameters for the network. For example, we can select that we have one level and the type of the pipes that we have. And I will select again OK. So now I can select the number of the circuit that I have. I need to select the place the circuits. On the in-floor heating system, I'm going to use the vertical pipe dot number of circuit on the software. That means that if I select 1.1, that means that I have the first circuit that belongs on the first vertical pipe. Is vertical pipe dot circuit the type that I'm going to use. And after that I need to place the vertical pipe that I have. For example, 1, enter. So now I can go to the first circuit and select right click and options. Here I can place the parameters for the network. For example, I can select the space load. The space load that we had calculated was 3.4. We can select the surface. I think it was, let's see, 28. It was 28, and now I can select the pipe distance between the drawings and select close, so the calculations for the network have been made. Now I can go and see on Windows again the hot water storage calculation. It's the same calculations as we had seen on the two-pipe system, and the boiler selection again the same as on the two-pipe system, and the only thing that will change is the vertical diagram. The vertical diagram will be calculated from the calculation software. So I will calculate the vertical diagram here and not on the drawing as we had previously made. So here is the vertical diagram, and I will go vertical diagram and export to DWG. So I can open after that drawing on any CAD software. And again, all those parameter printouts can be linked to Word. So let's save and close. Go again on the drawing, and here we cannot update from drawing. That means that if we want to place the basic parameters on some labels, we need to create those parameters here by hand. So those are the basic parameters, the basic calculations. I don't know if you want to see something else, something more.
Because I think the basic concepts are shown.
Yes.
Now we are not experts in our emails. And that's why we ask also to record the session, because we need to check it a little more in detail. And for sure after we will have questions about the more specific and more technical stuff. But the basic concept on the flow, on the workflow, I think it was shown very well.
Yes.
From our side, it's very good.
Yes, that was a basic parameters in order to understand the flow that the project will, that we are going to work on a project. And after that, specific questions, specific things on every network can be seen also on a different meeting.